If you ask Google what are the toughest exams in the world, it will be surprised to understand that there are 3 exams from our Hindustan, from our country, India. Out of 3, one is Civil Services Examination, the second is IIT JEE Entrance Examination, and third, our exam, Graduate Aptitude Test in Engineering. You know guys, I really feel privileged to be one of the faculties of Graduate Aptitude Test in Engineering subjects for Electronics and Communication Department. I'm one of the faculties who teach electronic devices as well as analog electronic circuits. Guys, you know, in this session, let us concentrate more on the preparation strategy to give up a very good, the way how we go with the electronic devices examination. Our target is to get a very good score in the exam with a proper subject. I believe, correct or not, dear students, right? Students, if you understand electronic devices, many students asked me, sir, why should I study the subject called electronic devices? What is the need of electronic devices? Guys, you know, what I understand as per my experience in case of these electronic devices, this subject deals with the device course, which is a basis for analog electronic circuits and digital electronic circuits. If you check it out, the electronic devices, my dear students, electronic devices are of 2 types, I hope you know that. One is analog electronic circuits, the other is what here? Digital electronic circuits. For your kind information, in this course of electronic devices, you are supposed to concentrate more on the device part. Don't concentrate on the design part. Please understand my word. For example, let me say Zener diode. If I go with a Zener diode, you are supposed to go with the construction of Zener diode, the way how Zener diode react when I apply forward bias, how it will react when I apply reverse bias, what is the statistical approach to proceed, a breakdown picture of a Zener diode, and what could be the VI characteristic of a Zener diode. We need to stop there, and we need to hand over this VI characteristics and our thesis to the design engineer. We are not design engineers. As per this subject, we are device engineers. Now, design engineer will take care of considering our thesis. Then based on their need, they go with the load line analysis. You know load line, am I right, dear? So based on the selection of load line, whether that load line, they are biasing before breakdown or after breakdown, based on that, they go with applications. For example, based on the load line, if they select the quiescent point or operating point in the breakdown region, they can use Zener diode as a voltage regulator. I just don't care how they are using the Zener diode, because my target is to what? Go with the VI graph, VI characteristics. To get a VI characteristics, we are supposed to discuss about the device. We should discuss about the construction. Let me go with the bipolar junction transistor in the same way. We are supposed to go with the VI characteristics of BJT, the construction, the working principle, that's it. Once we got VI graph in a very proper way, submit that to the design engineer. So they go with the load line. Based on their approach, biasing techniques, stability techniques, they select the quiescent point in a proper way. If they select the quiescent point in the active region, analog design engineers, they use it as an amplifier. If they select the quiescent point in the cutoff or saturation, digital design engineers, they use it as a switch. It is their wish, okay? But our target is to produce the VI characteristics. So you please limit your study as per the subject what we have. I believe you got the point, dear students. So in this session, we are serious about the statistics, what we need to follow to get a very good success rate in this electronic devices of Graduate Aptitude Test in Engineering. Guys, so the preparation strategy, as per my experience, and by collecting the historical data from a successful student, okay, not one student, from successful students, okay, I'm going to discuss about the preparation strategy in this. In the second session, which is going to held on next week, Wednesday, 6th, I understand, you know, there we'll discuss some important concepts. By that, how can we save a lot of time to give a great highest success rate in electronic devices in a short span of time, as per the timing what they have allotted for GATE examination. Guys, you know, once we go with the syllabus, let me say electronics and communication, mean to say GATE exam, electronic devices syllabus. I appeal to everybody, concentrate more on the syllabus. What you have in the syllabus, please go deeper into the syllabus. What you don't have in the syllabus, my appeal, try to skip. What is not there in the syllabus, try to skip. For example, one student, he asked me, see, regularly students, they will communicate with our ACE Academy faculty, okay? One student recently, he asked me, sir, is it must to study junction field effect transistor to understand MOSFET? Then the only answer I can say, there is no rule. Why? Because in your syllabus, what you have is enhancement MOSFET. To understand the enhancement MOSFET, there is no rule that you're supposed to study depletion MOSFET. There is no rule that you're supposed to study junction field effect transistor. My humble request to you guys, don't waste your valuable time to study what is not in the syllabus. Once upon a time, electronic device indicates it's a vacuum tube. Olden days, scientists used to thought, without understanding vacuum tube, we can't understand transistors. Today, are you studying vacuum tubes to understand transistor? The triode, pentode, tetrode, are you studying that? No, you're directly studying semiconductor electronics or semiconductor physics, am I right, dears? So please consign yourself. My humble appeal is that you have MOSFET, go deeper into the MOSFET, MOS diode, MOS capacitance, practical MOS diode, ideal MOS diode, go into the deeper. Field effect transistor, as per the GATE exam, you don't have, don't touch that. I believe you got the point. That is the main reason why I'm serious about to disclose the syllabus, what you have in the GATE exam. And of course, GATE 2021, there is a modification in the syllabus, the updated syllabus. I'm disclosing onto the screen. Have a look carefully, guys. So we have energy band analysis in intrinsic semiconductors as well as extrinsic semiconductors. Concentrate more on that. And we have equilibrium carrier concentration and a direct band gap, indirect band gap semiconductors. And we have carrier transport. Carrier transport indicates the drift currents we have, diffusion currents we have, recombination currents. When you hear the word drift, yes, mobility and relation of mobility with the temperature, many parameters need to come into the mind, right? In a similar way, generation, recombination of carriers play a very vital role to discuss about a direct band gap as well as indirect band gap. And of course, we have continuity equation, and we take a help of Poisson's equation to discuss about electrostatic field profile, right? Maybe a PN junction, maybe a MOS diode. Similar way, we have PN junction, Zener diode, bipolar junction transistor, MOS capacitance, and MOSFET. No JFET, please take care of that. And light emitting diode, photodiode, and a solar cell. So there is no laser in your syllabus. Maybe that is important for engineering services, not for GATE exam. And sir, where I can use this electronic devices syllabus in my career? Yes, that is an important question. See, sir, I'm preparing for this GATE exam, so-called the syllabus what you have disclosed. Other than GATE exam, can I use this syllabus in any other competitive exams? First question, is this syllabus useful for me in my future life? Maybe any companies like that. Is this syllabus is useful for me? I think if you can understand that, I believe that adds a great flavor for your preparation. I believe, correct or not, dear students? For that purpose, let me check it out. See, go with the syllabus what I disclosed onto the screen. And this is the syllabus for engineering services. And in engineering services, we call the subject name as basic electronics, okay? Go with this here. Yes, basics of semiconductors, the same what we covered in the GATE, diode, transistor behavior, characteristics, and you have modes of different uses, and you have a junction field effect transistor, we have a diodes, we have a field effect transistor. This is interesting. In this, engineering services, guys, you have JFET. Yes, man, you have JFET. Then here, you're supposed to concentrate on JFET, because strictly, we are supposed to follow the syllabus. Whereas for GATE, you can avoid JFET, right, dears? And of course, basics of integrated circuits. Yes, this is also we are supposed to cover in case of engineering services. And BJT, MOS, and CMOS integrated circuits. And of course, we have optical optoelectronic devices, like we have basic optoelectronics like light emitting diodes, photodiodes, and a solar cell. Even here, you can cover laser also, because they have not specified that we have LED photodiode like that. So basic optoelectronic devices, what we have, in that laser need to be added. So here, you're supposed to cover laser. Sir, where can I use the same syllabus other than this? Guys, you have multiple exams. I'll be discussing that. Before that, let's go with the weightage here in case of graduate aptitude test in engineering. Guys, if you go through here, in 2020, 2 1-mark questions you got, and 5 2-mark questions you got. 5 to 10, 10 plus 2, 12 marks. 12 marks in 2020, that is amazing, right? In 2021, 2 plus 2 to the 4, 5, 6 marks. In 2022, 4 1 marks and 3 2 marks. Whereas in case of 2023, 3 1 mark and 2 2 mark questions you got. In the similar way, if you're going for engineering services, guys, basic electronics part, that is electronic devices part, how many number of questions you got? If you ask me, 2019, very few questions, 3 questions. 2020, damn very few, that is 2 questions. 2021, 8 questions. 22, 8 questions, and 23, amazing man, 15 questions you got in basic electronic subject. Now, yes, guys, if you check it out, in this case here, other than GATE and ESE, where I can use, if you ask me, yes, DRDO scientist B, there is a very good weightage in our electronic devices. Not only that, Baba Atomic Research Center, I hope you can understand. Baba Atomic Research Center, they're accepting GATE exam. Not only that, they're accepting CSIR NET exam, Council of Scientific Industrial Research, CSIR NET exam. Not only that, Baba Atomic Research Center, they're conducting their own exams, right? So I understand 2023, April 8th, this exam was done. If you go through the syllabus and if you go through, the questions, they are strictly following the reference syllabus of graduate aptitude test in engineering. So your preparation of GATE exam of electronic devices, you can use in engineering services. You can use in DRDO Scientist B jobs. You can use in Baba Atomic Research Center. You can use in University Grants Commission, UGC NET. You can use in Indian Space Research Organization, ISRO, ISRO, and many more exams, man. And not only that, the universities like IIIT Hyderabad conducting separate exam. You can use the same syllabus here. Vellore Institute of Technology conducting separate exam. Almost a similar syllabus here. IIT Delhi, Indraprastha Institute of Information Technology conducting a separate exam. Yes, you can use here. And even National Institute of Electronics and Information Technology, yes, the similar syllabus you have of graduate aptitude test in engineering of electronic devices. Not only that, BITS, Birla Institute of Technology, BITS Pilani, BITS Goa, BITS Hyderabad. Yes, man, these are all the universities. They are conducting separate exams other than GATE exam to pursue the post-graduation programs. So if you prepare for GATE exam under a proper guidance with a proper preparation strategy, I understand you can use the same pattern or a same syllabus in multiple exams, such a way that, unfortunately, if you miss one exam, no problem. You may miss exam, but your preparation will not be missed. A student may fail in the exam, but he never fail in the preparation. Why? Because his preparation can be used in multiple exams. If his preparation is proper and if his strategy is awesome, okay, in any one of the exam, he'll be experiencing a great success for sure. So please take care of that. That means you're preparing for electronic devices or analog circuits or a digital circuits or a network theory. Understand you are not only preparing for GATE. Related to GATE, there exists a lot of exams you have. Maybe public sector undertaking, PSUs, local, state government PSUs. Maybe like Andhra Pradesh Public Service Commission, Telangana State Public Service Commission, Tamil Nadu Public Service Commission, State Level Public Service Commission, right? Not only that, UGC NET, CSIR NET, and the individual PSUs conducting their own entrance examinations. Many of those exams, they are taking the reference syllabus of GATE exam itself. Standard may vary, exam to exam. The way how they ask questions, the standard may vary, but the syllabus is almost similar. So your preparation, you can use in multiple exams. This is amazing part of preparing graduate aptitude test in engineering. So we should give a big salute to GATE panel who prepared a beautiful syllabus. And the students who want to pursue the post-graduation programs in robotics, post-graduation program in artificial intelligence, post-graduation program in nanotechnology, embedded systems, microelectronic capsule, and VLSI, my favorite subject here, VLSI design, and of course, doing post-graduation program in 5th generation 5G technologies. I hope you know that. To run an autopilot electric vehicle systems, you need a 5G technology, right? So in India, many companies started doing research on these 5G technologies. So doing post-graduation program based on these technologies, yes, man, you need the subject of electronic devices, analog electronic circuits, design engineering, device engineering. Both are needed. Guys, okay? So I believe at least you got some conviction. Why should I study this subject? Where I can use this subject? in how many ways I can utilize the content what we have in the graduate aptitude test in engineering. So the only answer from my side, sir, is this subject important or not? Because some students ask me, sir, EDC is important, EMTL is important, analog circuits is important. Sir, I left that subject, I left this subject. A small question I want to ask you. In engineering, I think you guys are having 45 to 48 subjects. I think I'm right, 45 to 48 subjects. Out of those subjects, your IIT people or a GATE panel people, they have chosen only 8 technical subjects, 2 non-technical subjects. That is, for electronics and communication, you have only 10 subjects. Out of 45 or 48 subjects, they have chosen only 10 subjects indicates understand the value of those subjects in the practical world. If the subject is not having any value, why IIT professors will be choosing those subjects? And after having a great value of those subjects, you are asking me, sir, is it important or not? Absolutely, it is important, man. You are supposed to study. No other choice you have. Because every subject is having a very great practical exposure. In that way, IIT professors frame the syllabus. This is one of the main reasons why most of the exams, maybe IIITs or VIT, Vellore Institute of Technology, BITS Pilani, BITS Goa, BITS Hyderabad, or Bob Atomic Research Center, or many other exams, many PSUs, they are taking the reference of GATE exam syllabus. Most of the exams reference, they are taking it as a GATE exam syllabus. You can have a proper back test to get a confirmation. Am I right here? Now let's have a beautiful analysis. Guys, many students ask one more question. For those students, I want to show this as a display. Sir, if I do post-graduation programs, do I have, I'm going to say, will I get a good job? If I do the post-graduation programs, will I get a good job? And if I do post-graduation programs, my GATE exam subjects, are they useful? Yeah, that's a good question. If I do the post-graduation programs, my GATE exam syllabus is useful or not? This is one more question I'm experiencing a lot from many students. For those students, I want to show you a practical proof. Guys, in one of my favorite universities, there was a campus placement. I'm disclosing just one university placement. At least I believe you get a conviction. I should not disclose what is that university, so here I'm not disclosing the university name. And this is the data what I got directly from the university itself. Is it okay? And of course, see the Department of Electrical Engineering. If you go to the standard universities, maybe IITs or IISc Bangalore or IIITs, okay. If you go to the standard universities, electronics and communication, they call it as a branch. Whereas the branches belongs to the electronics or electrical. They form a single department called electrical engineering. That means tomorrow if you do MTech in embedded system, you'll be getting award or a degree as Department of Electrical Engineering, MTech in VLSI, but the Department of Electrical Engineering. So all these comes under a single department called Electrical Engineering. Guys, okay? So check it out. The salaries, what they got. The lowest salary, 7 lakhs, highest salary, 39 lakhs, and a median salary, 19.16 lakhs. I'm not showing you the package or a CTC, right? CTC indicates how much the company is spending on a particular person per year. This is salary, which is almost equals to amount is getting credited in your account, okay? So for example, a student got a salary, a CTC of 6 lakhs, salary maybe around 4.5 lakh or 4.8 lakh, that depends on that, okay? So I'm talking about a salary. So I'm going to say the median salary is 19 lakhs is not a small amount, I believe, guys, for freshers, okay? And check it out, the companies like AB, InBev, Adobe, Advanced Micron Devices, excuse me, AMD, Advanced Micron Devices. Check it out, the job profile, design engineer. Yes, that is important, analog design, digital design, where they need a device. And of course, you have American Express. See here, the company name itself is Analog Devices, one of the famous companies in the world, okay? Analog Devices, design engineer, the job. Analog Devices, APC engineer, audio processing and applications connectivity engineer, okay? One of the best positions here. And Analog Devices, embedded system-based job. And you have ANI Technologies, ANC support, Cisco, and many more companies you have, right? You have a Google, you have a Hyundai, you have Indigene, you have Intel Technology, you have Indian Space Research Organization, Jaguar, Land Rover, JP Morgan, MathWork, Micron Technology, and NAND product engineers for Singaporean Micron Technology, Microsoft, NVIDIA. You know, guys, one of my favorite companies in the entire world based on artificial intelligence is NVIDIA. First company in the world, I mean, it's the best company in the world for AI, artificial intelligence, is NVIDIA, and second top company is Broadcom. Okay, yeah, you have NVIDIA on semiconductors. Understand, man, and the job profile is analog designer, design engineering. Understand my word carefully, okay? And Oracle, PayPal, Qualcomm, right? So you have Reliance, Rivigo, Salesforce, Samsung, research and development, Samsung, semiconductors you have, and SAP Labs, Taiwan semiconductor manufacturing companies, guys, okay? And you have TCS, Texas Instruments, analog engineer, Texas Instruments, digital engineer. Understand the value of the subject, what you're preparing for the gate, okay? And you have TVS Motors, assistant manager in electronics, research and development, R&D, okay? And Virtusa Corporation, Western Digital, Wipro Technologies you have. Yeah, many more companies you got. If you count, it is almost like a 73 options. Even Zensar Technologies recruiting you guys. Now, please tell me, is it worth of doing the post-graduation programs in the standard universities? Yes, yes. If you do the post-graduation program in standard universities, yes, no doubt, you will be having a fantabulous career for sure. And please take care, do the post-graduation program in technology-based courses rather than generalized courses, like MTech in VLSI, MTech in embedded systems, MTech in fifth generation technologies, MTech in electric vehicle technology, MTech in artificial intelligence and robotics, like that. Choose a technology-based program, do the post-graduation program in those technology-based courses. So, guys, if you prepare for GATE exam with a proper strategy, guys, you can go for PSUs, government organizations like Maharatna companies, Navratna companies, Mini Ratna companies. I hope you know that. Around 26 PSUs accepting your GATE exam, and they're giving very high packages for those guys. And you can do the post-graduation programs, and you can go for management programs like, NITI Mumbai, National Institute of Industrial Engineering Mumbai. Recently, it was changed its name to IIM Mumbai, Indian Institute of Management Studies Mumbai. You know, for PGDIM program, yes, they're accepting GATE exam, Graduate Aptitude Test in Engineering. Not only that, you can go for the research organizations like a DRDO, Defense Research Development Organization, Bob Atomic Research Center, whatnot, man. And I hope you guys knows that if you do the post-graduation program, anywhere in India, it may be MTech or MS like that, anywhere in India, any college, any university, which is under MHRD, like central government of India is giving you a stipend, right? You know that, 12,400 rupees per month. That means per semester, it is almost like a 75,000, and per year, it is almost like 1.5 lakh. Oh my God, I think almost it is like a free education, almost, okay? So thanks to great GATE exam, Graduate Aptitude Test in Engineering. Such a fantabulous exam is GATE. So for every subject, you must be having a proper preparation strategy, which is very important. So in this session, for my subject, so-called electronic devices, okay? So what could be the best preparation strategy? I'm going to discuss you in this session, dears. And my name is M.M. Trinath. I'm the faculty of ACE Engineering Academy, one of the faculties who teach electronic devices as well as analog electronic circuits. And for your kind information, guys, many people are saying that you have VLSI part. No. Please understand that. You have only electronic devices. Just open the syllabus and go through that. You have only electronic devices. No VLSI in case of GATE. Graduate Aptitude Test in Engineering. Don't make it complicated word, okay, VLSI. VLSI is very, the next level subject, I could say. That is not under your GATE. And you know that even third years can write GATE exam. Many of the universities in India, final year students are having VLSI. Third years, they don't have VLSI. So don't put VLSI in your syllabus of Graduate Aptitude Test in Engineering, right? So, guys, as the strategy, if you understand, go with the syllabus once again. You know, guys, how I divide the subject. I need to save a lot of time because you have 1 mark questions as well as 2 mark questions, right? 1 mark question, the allotted time by GATE panel is approximately 1.5 minutes. That means within 1.5 minutes, you're supposed to get the answer of 1 mark questions. Whereas 2 mark questions, the allotted time by our GATE panel is almost 3 minutes to 4 minutes at max. Maximum you can take it as a 5 minutes, it's okay because you can manage the timing. So within 4 to 5 minutes, you're able to get the answer. In that way, you need to follow the statistics. So for that purpose, practice is very important, and short notes play a very vital role. I'll tell you, for example, guys, first, as per the syllabus, you know what I concentrate first is currents. Currents in semiconductors. See, in my electronic devices, if you already prepared for electronic devices, I think this adds a great flavor. And if any student want to start the preparation of electronic devices for the GATE exam, please try to follow this easiest strategy and try to understand the way how we can complete the syllabus maximum within 1 month in the preparation. Okay, so once I start the subject, the very first I start with currents in semiconductors. When you hear the word currents, yes guys, you have drift current, you have diffusion current, and you have recombination current. And guys, when you hear the word drift current, write down everything that what drift current covers. What is the first point of a drift current? The current which is strictly depends on applied electric field. Second, drift current covers with the mobility. Third, mobility relation with the temperature. Mobility relation with the doping. Am I right or wrong, dear students? So all this comes under the drift current parameters. So this is the drift current which is strictly depends on what, dear students? Electric field, or a current strictly depends on voltage. In the similar way, the next current what we have is a diffusion current. Whenever you hear the word diffusion current, what you need to recollect? Diffusion current. This is the current which is strictly independent on electric field. No need of providing an electric field, but you're supposed to maintain a concentration gradient. There is a slope. The carriers jumping or moving from high concentration to low concentration. Then if those carriers participate in a current without any electric field, then that is responsible for diffusion current. And because of the diffusion current, if there exists recombination, because of diffusion current, if there exists recombination, then there exists built-in electric field. Due to that built-in electric field, there exists equilibrium. At equilibrium, the net current equal to 0. Then you will be getting the current equation, equilibrium current equation. I believe you got the point or not. So once you hear the word currents in semiconductors, the total concept must be rounding around your head. That's it. In that way, maintain the short notes. After maintaining the short notes of these currents in semiconductors, okay, like some important points, try to maintain the short notes of around 30 to 40 points, max 30 to 40 points, which should cover everything. Then you please check it out. What are the questions they're going to ask in the exam? Regarding the drift current, what they ask? Find the conductivity, find the mobility, and if temperature is varied, what could be the conductivity? So if temperature is at 300 Kelvin, if conductivity is this much. If temperature is at 400 Kelvin, what could be the conductivity? That means you need to write in what way they can ask questions in the examination. Regarding drift current, in what way they can ask questions. Regarding diffusion current, in what way they can ask questions. Regarding recombination currents, in what way they can ask questions, like a carrier lifetime. And here you'll be getting a beautiful concept called Einstein's relation, which is happening at equilibrium condition. Correct or not, dear students? So this is the way how you need to start with the subject. Now, energy band. The second, what we say, the point, I mean to say second part of your electronic devices, what I consider is energy band. Students, when you hear the word energy band, yes, you should understand, we have the valence band, we have conduction band, and we have energy gap. Guys, whenever you hear the word energy gap, you can understand that conductors we have almost negligible energy gap, semiconductors a moderate energy gap, insulators there is a huge energy gap where you're studying since 11th and 12th classes, I believe. Even for MSET exam, I believe you prepared this, a very basic. Now here in engineering, what is the upgraded part of energy gap here is, yes, you're right, energy gap dependency with the temperature. If temperature changes, energy gap changes. What is that? You know that, guys, energy gap at a particular temperature, T kelvins, is equals to energy gap at 0 kelvins minus beta T, am I right? This is the relationship between energy gap and temperature. That means if temperature increases, energy gap decreases. Correct or not? So energy gap strictly depends on temperature. Energy gap strictly depends on the type of material. For germanium, energy gap is different. For silicon, energy gap is different. For insulator, energy gap is different. For conductors, energy gap is different. So it strictly depends on, no doubt, the material, the type of material. For gallium arsenide, so-called compound semiconductors, energy gap is different. And also slope in the energy levels. This is the second point. You should understand the energy band. What is the slope? Very simple logic, guys. If you understand that, guys, we know that energy is always nothing but capacity to do work. Correct or not? Capacity to do work is nothing but what, dear students? Energy. So W equal to VQ, I think you can remember this. Voltage is equals to work done per charge, or W equals to what, dear? VQ, am I right? Now, please tell me, my dear boys and girls, whenever you hear the word electric field, what is electric field? Electric field, can I use the word minus del V? Electric field is nothing but what? Minus del V. Or simply I can say minus dV by dx. This is perfect. V is nothing but voltage. Now, if I can consider these two relationship, please tell me, guys, if I have these two relationship, now am I getting any sort of conclusion here? Am I getting any sort of conclusion? Please let me know, my dear students. So electric field, if I take, which is equals to, speak out, guys, what I'm going to get here. So minus d by dx of voltage. What is voltage? Voltage is equals to W by Q, or energy by Q. So this is energy by Q, which is nothing but what, here? Voltage. Of course, most of the cases, default, we take electrons. Electron is having a negative charge, so I could say this is minus. Therefore, if I say electric field, speak out, guys, electric field is simply equals to 1 by Q times d of energy by dx. My God. So, excuse me, what did you understand from this? That means simply doing maths has no meaning. And for our engineering, we don't have a simple maths. We have engineering maths. That means what equation you're doing. For every equation, there must be a reason. Engineering reason is needed. A practical application is needed, right? So what it is showing here, electric field is equals to 1 by Q times d of energy by dx, indicates very simple answer. If I plot the graph between energy versus distance, x-axis is the distance, y-axis is energy, right? Let me assume I got a slope. I mean to say I got a graph in this way. For example, this is EC level. You know EC level, right? The lowest energy level of conduction band, EC. And if you have EV, the highest energy level of valence band is EV, right? And here, this difference is simply energy gap. Now, could you please let me know if any slope I have? Y-axis is energy, x-axis is distance. Now, what is the slope here? dEC by dx. Of course, it is equals to dEV by dx. Could I understand what is the slope? 0. Sir, if slope is 0, substitute that here. If slope is 0, d of energy by dx is 0, I think electric field equal to 0. So what do you mean by that? What do you mean by that? For any device, if I draw the graph or the characteristic behavior between energy versus distance of any device, maybe a MOSFET, maybe a MOS diode or MOS capacitance, maybe a PN junction, maybe a Zener diode, maybe a varactor diode, maybe a bipolar junction transistor. Y-axis if I take energy of a particular device, and x-axis is a distance, the particle of a device. Y-axis is energy, x-axis is distance. If there is no slope, then that device is not experiencing any electric field. My God, yes, it is not experiencing any electric field. Whereas, for example, if I plot the graph in this way, y-axis is energy and x-axis, I say distance. Now let me assume that graph is having the slope in this way. This is EC and this is EV. Yes, man, you have the slope here, am I right? You have the slope dy by dx. That means what? Here there exists a slope. There exists a slope in the energy. X-axis must be distance, y-axis is energy. There is a slope in the energy. Whenever there exists a slope in the energy, now that is a device which is having electric field. So that device is supporting electric field. This is amazing. Excuse me, correct or not, dear students, right? So this analysis is very important while studying about energy band analysis. That means what? Engineering maths you're using here, engineering physics you're using. You're not using simple physics, you're using engineering physics. In a similar way, energy band indicates, see, once you're studying about energy levels, you're supposed to go with a Fermi energy analysis. So study in a proper way, guys. The entire subject of electronic devices, it will be dealing with this energy band analysis. The slope in the energy band under the Fermi energy levels, equilibrium conditions, in equilibrium conditions, everything will be covered a beautiful way while studying about energy band. Try to spend more time in this energy band analysis. Of course, it covered many equations. You know, when you hear the word Fermi level, it covers the concentration of electrons in conduction band. I mean to say Boltzmann equation based concentration of electrons like N is equals to NC exponential EF minus EC by KT. N is equals to P equals to NV exponential EV minus EF by KT as per Boltzmann condition. If Boltzmann approximation is failed, we have Joyce-Dixon approximation to find the concentration of electrons in conduction band, to find the concentration of holes in valence band. The Fermi level analysis is very important. Fermi level is very important to identify whether my device is operating under equilibrium or in equilibrium. If you don't know whether my device is under equilibrium or it is under inequilibrium, you can't understand BJT. You can't justify MOS diode. You can't go for VLSI fabrication in future. So that is very, very, very important concept with respect to the Fermi energy analysis. And if you really don't understand about Fermi level, you can't understand mass action law. If you don't know about mass action law, then you can't understand the way how we are getting currents with respect to the conductivity. Current dependency with the temperature, conductivity dependency with the temperature, conductivity dependency with energy gap, built-in voltage dependency with energy gap, everything is related with the mass action law. That everything you need to cover in Fermi energy. So once you hear the word Fermi energy, just you need to recollect whatever topics you have, whatever relations you have based with Fermi energy analysis. Please, my dear students, okay, take it as a very serious task. Maintain a fantabulous notes. That is very important. Right. What is the next topic? Energy gap. Just now, I believe I covered. It depends on the temperature, depends on the type of material, and of course, relation with the built-in voltage, just now I discussed, and of course, dependency on wavelength. Yeah, this is very important. Energy gap, dependency on wavelength. I hope you know this formula. Energy is equals to 1.24 by lambda. Of course, it must be in micrometers, and units must be electron volt. So energy inversely proportional to lambda. This is one of the very important relations. Once you're studying about optoelectronic devices, especially the photodiodes, and second is light emitting diodes. Okay, so this is one more very important dependency, energy gap with respect to the wavelength. And of course, a lot of previous gate questions you have. Then the next topic, what I go with the Fermi level, as just before I have discussed. Fermi level at equilibrium and in equilibrium. Fermi level with respect to the PN junction when it is bias. BJT at equilibrium and BJT under bias. MOS capacitance under equilibrium, practical MOS capacitance. MOS capacitance indicates there it is a MOS diode, okay, MOS diode. Practical and ideal MOS diode and MOSFET, where you will be experiencing a body effect, which is nothing but non-idealities of MOS. So their body effect, this Fermi level play a very vital role. Guys, okay, so you need to, this is the way how you need to prepare the short notes. If you hear the word Fermi level, write everything, whatever it must be covered in the entire syllabus. Don't say that Fermi level is the first unit, MOSFET is the 5th unit. Please, guys, everything is interlinked. Nothing is first unit, nothing is 5th unit. Is it okay? Just for observations purpose, we divided that as unit-wise, which shows that from basic level to advanced level, we divided as unit 1, unit 2 like that. But once the syllabus is completed, you need to interconnect the topics. There is a lot of interlinking between one topic to other topic. If you could able to understand, success is yours. In a similar way, electric field profile, very important. After energy band diagram, the total electronic devices, they are standing on this electric field profile. Sir, why should I study electric field profile? It may be for PN junction, maybe for bipolar junction transistors, and maybe for MOS diode. Sir, why should I study this electric field profile? Very simple answer. If you want to understand the relation between depletion width, and doping concentration. That is, whenever doping increases, depletion width decreases. If you want to find relationship between that, I need electric field profile. If you want to find the relationship between electric field and built-in voltage with respect to depletion width, yes, I need electric field profile. If you want to understand that, electric field will be maximum only at the junction. Yes, I need to understand about electric field profile. If you want to understand the capacitance of a diode, yes, man, every junction is having capacitance. I need electric field profile. If I want to justify the relationship of built-in voltage with respect to the doping concentrations under Fermi level, yes, man, I need electric field profile. Please understand the beauty of electric field profile in the entire subject of electronic devices. See, try to classify that. See, make it easy. Don't make it complicated. Life is simple, man. Make it easy. You know, my professors always used to say a point. In the world, everything is easy, but to know that it is easy is only difficult. In the world, everything is easy, but to know that it is easy is only difficult. You guys will rock because you're preparing for GATE exam. You know, guys, I always give respect for the people who prepare for GATE and a high respect for the people who qualify in the first attempt. You know why? Many students asked me, sir, why are you giving good respect for preparing for GATE? I mean to say GATE preparing students and IIT JEE preparing students. My only answer is the student who did not study in IIT, who don't know the level of IIT, who did not, give up any exam of IIT professors, who has not taken any training from IIT professors, but still they are writing an IIT entrance examination. Itself is the first success. Not only writing that exam, man, they are getting qualified in that exam. That student is having talent. Not only getting qualified, they are getting very good score in that exam. That student is having command in the subject. A student who has command in the subject, he must be having confidence and clarity about what he is doing. A big salute for that intelligence. Guys, I believe got the point. So feel proud of preparing for graduate aptitude test in engineering. Okay, every time feel proud of yourself, right? Now, next is capacitance. Yes, very important. So capacitance of a diode and mass capacitance. When you hear the word capacitance of a diode, you know that under open switch we have a capacitance. Under forward bias we have capacitance. Under reverse bias we have capacitance, so-called depletion capacitance, diffusion capacitance. Diffusion capacitance is also called as a charge storage capacitance. Depletion capacitance is also called as a transition capacitance. Am I right? So here, when you are studying about capacitance of a diode, try to recollect the relation between voltage versus capacitance, relation between lifetime versus capacitance, carrier lifetime with capacitance, relation between the current with respect to capacitance, and try to draw CV characteristics, capacitor versus voltage characteristics. And here, mass capacitance, yes, even here you're supposed to go with the CV characteristics, accumulation region, depletion region, inversion region. 3 modes of operation. You know that mass diode will be working under 3 different modes: accumulation, depletion, and inversion. So by taking the reference of electric field profile, we go with the capacitance, what happens in accumulation region, capacitance, what happens in inversion region, capacitance, what happens in depletion region. Based on that, we draw CV characteristics of a mass diode. And what formulas we are getting in that beautiful analysis, please put pen on the paper. And those are the questions where you got from past 15 years of your GATE exam under electronic devices. Thanks to this mass capacitance, which has given wonderful insight to understand about MOSFET. If I don't know about mass capacitance, then I can't understand the threshold voltage of a MOSFET. If I don't know the threshold voltage of MOSFET, how can I find VI characteristics of a MOSFET? If I can't draw VI characteristics, I can't prepare any thesis. If I can't prepare a thesis of MOSFET, how can I submit this report to analog design engineer? And how can I support this report to digital design engineer? Then how can they draw a load line? And how can they select the Q-cent point? So we should be accurate before giving our thesis to design engineers. Guys, okay, please take care. Anyways, next we have device currents. I mean to say, this is the way how I'm classifying the syllabus, okay? Device currents. When you go with the device currents, yes, you have junction currents, You have channel currents. What is this? Arey man, PN junction, I mean to say, Zener diode, photodiodes, all these, and bipolar junction transistor, all this works under junction currents called as low level injections and high level injections. Whereas if you go for MOSFET or JFET or MOSFET, they will be working under channel currents. That's why we call them as N channel and P channel. So the principles what we use in a PN junction, Zener diode, photodiode junctions, those principles I can simply use for bipolar junction transistors. The name itself shows junction transistor because they follow junction currents. Whereas those principles I can't use in field effect transistors because they obey channel currents, not junction currents. This is a square law device. They obey square law. Field effect transistors obey square law. Whereas PN junction, BJT, Zener diodes, photodiodes, they obey law of junction. Law of junction. Guys, understanding or not? So the current equations are very important. That current equation decides the VI characteristics because this is the equation which includes current versus voltage of a device. Then we go with the VI characteristics. Once we draw the VI characteristics, submit to the design engineer. That's the beauty of electronic devices. Guys, okay. In the similar way, as I told you just now, VI graph, very important to understand BJT characteristics, Zener diode characteristics, optoelectronic devices like photodiode, Zener, I mean to say like solar cell, light emitting diodes, right, MOSFET, and of course the basic PN diode. The VI graph is very important to go with the quiescent point analysis and drawing a DC load line, right? Next, optoelectronic devices, last but not least, as per our devices syllabus point of view, we have photodiode, we have light emitting diode, and we have solar cell. Guys, in case of photodiode, you're supposed to concentrate on the principle of low level injection, analyzation of quantum efficiency, responsivity, and going with the photocurrent equation and types of photodiodes like a pin diode. You have avalanche photodiode, you have a Schottky photodiode. Like that, we have different photodiodes. Understand about the behavior of those photodiodes. A lot of previous questions, a lot of PSU questions also you have as per the historical data. In the similar way, solar cell. Guys, you know, when you're concentrating on the solar cell, concentrate on open circuited voltage equation, concentrate on the short circuited current equation, then please concentrate on the conversion efficiency and a fill factor. Fill factor play a very vital role in this solar cell, which covers a lot of previous gate questions. In a similar way, light emitting diode, which is last but not least topic in this optoelectronics. So in LED, wall plug efficiency, or we say quantum efficiency, which is very important. Then you have, this is internal quantum efficiency, guys, and this is external quantum efficiency. And while discussing about light emitting diode, please recollect what you have studied in direct band gap semiconductors and indirect band gap semiconductors. You know that when there exists recombination under direct band gap semiconductors, then the recombination energy released by the carrier will be in the form of a photon. So direct band gap semiconductors are very important in case of light emitting diodes. So this is the way how to classify your entire syllabus of electronic devices in a simplest form. Guys, understanding? So that short notes play a very, very, very vital role as per your preparation of gate, or it may be under engineering services. So this is what I think I have covered the entire syllabus what you have in your graduate aptitude test in engineering. And field effect transistor, you need to add extra in case of, I mean to say, engineering services. And of course, IC fabrication steps what you have, and a CMOS, complementary metal oxide semiconductor, CMOS. As an inverter, you should take it as a reference to study in engineering services, which is an extra topics compared with the gate. In a similar way, my dear students, what is the best approach if you ask me? As per historical data, this is the successful approach. I never said this is the only approach. I said this is the successful approach. By taking a lot of feedbacks from different successful candidates of many places, okay, we have prepared this. The first priority, try to give for the faculty notes. You know, guys, ESE Engineering Academy, you know, established in 1995. It is not yesterday or a day before yesterday. Understand, an organization running successfully since 1995, understand the experience of the management. Do you feel they will be recruiting normal faculty to teach to their students impossible. Correct or not? It is impossible. They'll be absolutely recruiting the students who has not only experience, also who has expertized brain, which is very important. So the faculty who are teaching in the ESE Engineering Academy of any subject, okay, try to give highest priority to study that faculty notes. Next, then important tricks. Shortcuts are very important. Time-saving techniques are very important. Please try to go with the tricks what faculties are giving and try to follow those tricks and practice at least 5 times numericals by going with those tricks. Not only that, guys, you please go with the numericals what faculty discussing. First, try to give highest priority for the numericals what faculties are discussing. Then only go for any other books. I just never oppose that you should not follow any other books, okay? I should never oppose that. But first give highest priority for the numericals what the faculty people of ESE Academy is giving to you. Then previous year gate questions, very, very, very important. Go through the previous questions. Then you understand the way how they're asking questions. Not only that, for example, today you solved one question, previous year gate 2023 or 2022. Assume you solved that question in 8 minutes. You have taken 8 minutes to solve the question. After 10 days, my humble appeal, go back and again solve the same question. Now please check it out what is the time you're taking. If you're taking similar 8 minutes, indicates there is no improvement in you. The same question, still you're taking 8 minutes. Indicates you're not following the techniques, shortcuts or time-saving techniques. After 10 days, if you're able to solve that question in 4 minutes, indicates you upgraded your knowledge. You updated, you upgraded. Then after 10 days, again you go through with the same question. If you're able to solve in 2 minutes, that is amazing, man. That is what I need. You test yourself. This is called back testing. Back testing will gives you conviction, which is very important. Right, and please go through not only GATE, also engineering services, PSUs, DRDO, Baba Atomic Research Center, ISRO, previous questions. Yes, ISRO, DRDO questions. And after that, please revise the notes. That is very, very, very important. Repeat the concept number of times, guys. That gives you a lot of convictions. And after that, please write the exams. This is very important. ESE Engineering Academy, they are conducting topic-wise exams, subject-wise exams. Syllabus-wise exams, and the total mock exams. So we are conducting a lot of exams to our students, not only for our students. Any student in the entire country who is preparing for GATE, they can enroll only for a test series of ESE Academy. You will be getting more than 50, more than 70 tests before going to the GATE exam or engineering services. If you're writing at least 50 exams conducting by reputed institutes in the entire country, that is ESE Academy, I think that gives you a lot of command in the subject. At least you'll get understanding where you're doing mistake. Am I right or wrong, dear students, right? With that analysis, by following a strict strategy, if you go to the exam, I think success is yours. Guys, so the full-length mock test, after November, you need to start to give up the exam. Is it okay, my dear boys and girls? One important thing here is, many students are doing mistake. I have seen this from one student. He started solving a numerical in my class. While I'm giving a question, he started solving a question. Surprisingly, he has taken 14 steps to solve the answer. To get that answer, he has taken 14 steps. And he said that, sir, I got an answer. I was success. I'm success. I got an answer. Then I said, no, man. No, that is not a success. Getting answer is not a success. Getting answer in the correct time is success. That is what I believe. So if you're getting any answer where it is crossing more than 8 steps, stop it. And again, restart the answer. Please rethink again, restart the answer. That approach is wrong. GATE exam, competitive exams like GATE or engineering services prelims, so-called objective test exams, objective questions, okay? Don't cross more than 5 steps. You need to get the answer maximum within 5, at max, worst case, within 6 steps. In that way, try to maintain, please, guys. Okay, solving answer by taking 1.5 page, 2 pages, I don't think so that adds the flavor for your time. Time savings are very important, okay, guys? And yes, strictly follow the syllabus and don't go beyond it. As I told you a number of times, what you have in the syllabus, go deeper into the syllabus. What is not in your syllabus, please don't touch that. And guys, as I discussed, past 10 years questions go through carefully. Try to solve the same questions even after 10 days. By that, you need to save a lot of time. You need to understand whether you updated or upgraded yourself or not. You need to back test yourself, guys. And take as many as mock exams. As I told you, the best reputed institutes of which is in India is ESE Academy. Follow our mock exams in a serious way, because before giving the question, we do a lot of back test, whether a student able to solve this question in a given time or not. We have a separate team, not only faculty. We have teaching assistants, we have a separate team we have for every subject almost. Even the teaching assistants will do a back test, whether this question a student able to solve it or not. If he find that a question is not good, I mean to say it is very high standard for a student, then he will give a feedback to ourselves, then we need to change the question. In that way, the system is running in most systematic way. Guys, okay, follow these questions, man. You will be getting rock. And yes, try to give a highest priority for the subjects and try to give a highest priority with the standardized books. And of course, once you think about the analysis, guys, this I am very serious to show to my students of ESE Academy and everyone, of course, who is watching this, just to boost up the confidence levels. 2016, 2017, 2018, if you go through the historical data, for electronics and communication, around 1.5 lakh, 2 lakh students used to write GATE exam. But after COVID, after 2020, I could say, in engineering colleges and engineering universities, electronics and communication admissions came down, correct or not? Because of that, if you check it out, how many students appeared in GATE for 2022 for electronics and communication, right? I think ECE they have not given. Yeah, guys, this is ECE report. I understand it is not EEE, it is ECE, electronics and communication. Guys, in 2022, if you check it out, it is almost like a 69,000. Around 69,000 students, they have given the GATE exam. Whereas if you check it out in 2023, it is around 55,000, around 14,000 difference for electronics and communication. This is ECE, guys, okay, not EEE, it is ECE. Around 14,000 drop. Guys, understanding or not? Why, sir? Why the students are getting dropped? First problem here is the students who are giving GATE exam, forget about GATE exam, who are taking the course of electronics and communication, they came down, right? Many students are giving highest priority for computer science, technical based courses like AI, ML, data sciences, like that. So the students who are entering into electrical, civil, mechanical, or electronics and communication, they have fallen down like anything. And I hope this may be not good for universities, but this is lucky point for you guys. Why? Why it is lucky? Why? Because if the competition is very less, the students who are writing GATE exam, if it is very less, if the competition is very less, then the probability of getting government job or probability of getting admission in standard university will be very high because competition has fallen down. And luckiest point here is 2024, we have parliament elections. Correct or not, dear students? Central government parliament elections and many state government elections, Rajya Sabha and Lok Sabha elections. Because of those elections, maybe state governments or maybe central government, they release lot of job notifications. Not only notifications, they release more number of vacancies. Not only that, they give a very high increment for the existing employees where you will be getting a new pay scale. So whenever government job vacancies are very huge and the people who are writing GATE exam is very less, indicates the students who qualified in GATE exam, they give highest priority for government job only. Let me assume 10,000 students qualified. Assume electronics and communication, next year 10,000 students qualified. So for electronics and communication, approximately 26 PSUs accepting GATE exam. On an average, each PSU, if they release around 200 job notifications, on an average I'm taking, some may release 500, some may release 55, like that. I am taking on an average 200. So 26 into 200, approximately I can say 5,000 jobs. So out of 10,000 ranks, 5,000 ranks will be choosing the government job. Now for remaining 5,000 students, what is the choice? I'll tell you the universities: IISc Bangalore, IIT Madras, IIT Delhi, IIT Mumbai, IIT Roorkee, IIT Kanpur, IIT Kharagpur, IIT Guwahati, 8 universities. IIT Hyderabad, IIT Bangalore, IIT Delhi, 8 plus 3, 11 universities. Dhirubhai Ambani University, Birla Institute of Technology, BITS Pilani, BITS Goa, BITS Hyderabad, National Institute of Technology, NIT Warangal, NIT Kurukshetra, NIT Delhi, NIT Surat, NIT Calicut. Like that, if I count, you will be getting at least 25 universities. In every university, let me say, you have 200 vacancies. I mean to say 200 seats. Why? Because let me say MTech in VLSI, 30 seats. MTech in Embedded System, 30 seats. Like that, if I say on an average, 150 to 200 seats if every university you have. So 25 into 200, 5,000 seats. That means what? For remaining 5,000 students, the probability of getting admission is very high. Almost every student can get admission. Why? Because the seats are getting vacant. Why? Because the students who qualified in GATE exam is very less, first statistic. Second statistic is election time. Because of election time, there is a huge number of government job vacancies. Because of that, if competition is very less, qualified students are 10,000. If 50% they go for PSU, the remaining 50% probability of getting admission in the standard university in this country is very high. At any cost, every student will get settled. That is the beauty of electronics and communication. Congrats to everyone in advance. Guys, okay. And one important interesting statistic I want to show you here. Guys, 2018, approximately 45% students used to go for campus placement. And 2022, 77% people, they're going for campus placement. That means the percentage increase in going towards the campus placement is very high. Let them go, man. Your competition got reduced. That is what you need. Okay? And it is, if your friend is willing to go to campus placement, encourage them. Motivate them to go for campus placement. Let the competition come down more, man. Is it okay? So, guys, regarding the ESE Academy notes, yes, of course, faculty will provide you the notes for sure. Not only that, ESE Academy will be providing a great study materials. We are providing 2 books. The first book is like volume 1. Second book is like a volume 2. Volume 1 is like a textbook. Volume 2, which contains like a workbook, which contains a lot of questions, numericals, answers, and solutions. Not only that, guys, we are giving handbooks, which includes, time-saving formulas, time-saving important points. So before going exam, if you go through those formulas, those important points for the entire branch, I think that is enough. It is like one sort of short notes, right? You can go with this handbook, guys. And yes, we are conducting a lot of exams, like a subject-wise exams, cumulative exams, full-length exams. This will give a great energy to the students, great confidence in their minds, which is very important. Right, dear students? And ESE Academy, yes, we have classroom coaching, guys. We have exclusive online coaching, and we have self-paced program, so-called pre-recorded videos. Guys, we have a separate app, that is ESE Online. Just download that app. Whatever course you are interested, you can choose that course. And through the app, 24/7, you can ask questions to the professors, whatever questions you have. So professors will be giving a reply from morning 9 a.m. to mostly evening 7 p.m. By that, within very short span of time, your doubt or query will get resolved. Okay, dear students, I believe now you got some clarity about the preparation analysis of electronic devices in this GATE or engineering services. So have a healthy and wealthy career. In our next session, my dear students, I'll be discussing some considerable important topics which can be covered in 1 hour. By that, how my students going to give me reply in the chat box. I need to wait for the next session, okay? So next session is on 6th, I understand. Stay tuned to ESE online platform, guys. Have a healthy and wealthy career. Thank you so much, dear. Namaste.